All right. Wow, wasn't that a very beautiful intermission video? Thank you to digital artist Sean Duran for giving us permission to use this video. So welcome to your breakout session. Thank you for taking the time to join us. I'm Sean Pfeiffer, Commercial Innovation Manager here at the International Space Station, ISS National Laboratory, otherwise known as the Center for Advancement of Science in Space, in short, CASTIS. This breakout session is intended for anyone interested in sending their research to the space station and what are the steps to get you there. I am joined by my colleagues and partners from the National Lab and NASA, Christine Kretz, Vice President of Programs and Partnerships, Dr. Liz Warren, Senior Science Program Director, Justin Doyle, Operations Program Manager for Payloads, and Jennifer Buckley, ISS Deputy Chief Scientist. Together, we are going to help you understand what it takes to send your research to the space station and how our amazing teams here at the National Lab and NASA will guide you along this process. After all, space is hard, it is challenging, but it's not impossible. Sorry. So I'm going to start out by explaining the very first steps, and I'm going to turn this over to Christine Kretz. Christine is going to discuss our different lines of business and opportunities to fund your project. And then Christine will be followed on by Liz Warren and Justin Doyle, where they will discuss what they look for from a science and technology and operations standpoint. And upon conclusion, we would love to take questions from you regarding how you can send your research to the space station. This is meant to be a very informal session, and I welcome questions at any time during this hour. And please, when you submit your question, please begin with your first name only, your company, university if applicable, and where you're located at. During this time, please bear with me as these questions come in. I will work to get these answered by our team. If your questions do not get answered, I apologize. However, everyone that has I apologize. However, everyone that has registered for this event will get a follow-up email with my contact information, as well as helpful links and a recording of this presentation in 1 to 3 business days. So I would like to start out, what does it take to send your research to the space station? Well, it all starts with an idea, right? When you're ready to explore your idea, I am likely going to be your first point of contact, or someone on my team will work with you to develop this idea into reality. The first of 4 questions I'm going to ask you and myself would be the following. Does this have a need to be in microgravity? If so, what is the benefit to life on Earth? Are you a US citizen? And lastly, how are you going to fund this? Not everything has a need to be in microgravity, and we encourage our principal investigators to explore their research further terrestrially or in a suborbital flight before spending their time and funds to go to the space station. If we haven't established a need for your research in a constant state of microgravity, I ask then, what is the benefit to life on Earth? Here at the National Lab, we are focused on benefit to life on Earth. So anything from drug development, advanced materials, helping you to see better or fight off disease and everything in between, if we can draw upon what that benefit would be, we would love to make this a reality for you. Anything that has to do with space exploration efforts or astronaut health, this is not our area that we operate in. We would most likely refer you to our NASA team. And so after establishing that benefit to life on Earth, I need to know if you're a US citizen or not. Since the ISS National Laboratory is a US national asset built and paid through US taxpayer funds, we're limited to only pursuing an opportunity if you're a US citizen. Now, that does not fully exclude our international friends. if you are not a U.S. citizen, although you have a pathway here through sponsorship or have a subsidiary here in the United States, we would love to hear from you. Lastly, we need to discuss how are you going to fund your research. Unfortunately, we are not a grant issuing agency, and we are very limited in scope to providing any type of funding. We do, however, provide up mass and down mass, which is the rocket time and astronaut time. And so this can run into the millions of dollars. For example, using 1 hour of astronaut time can cost you in US dollars $17,500. Your costs come into frame when you're developing your proposal. And so we have over 30 implementation partners that will bid on your project. Our implementation partners are certified by NASA, and they help package your research, get it on a rocket, and then they're going to help you translate the science on station and your post results. Depending on the complexities and the requirements of your experiment, you might need to fund this for a simple experiment anywhere between $200,000 to $500,000, and it goes up from there. We're going to hear from Christine shortly on funding opportunities and how we could connect you with these opportunities. So I want to begin with, if we get through these questions, Justin, if you could please pull up our 2-pager. So after we get through these questions, we want to move to our concept summary, which is a simple 2-pager that we're going to help you fill out. And during this process, I'm going to get together my team, everything from our science teams, our operations team, and we're going to work with your team to start on your concept summary. So this is our concept summary. You can see right here. And at the conclusion of this event, I will be sending this concept summary out to everyone that's registered for this event. And so throughout this process of developing your concept summary, it's very important to us that we work with you to develop and submit a strong concept. Thanks, Justin. So after your concept gets approved, that takes several weeks. We internally review that here at the lab. After your concept gets approved, we welcome you at that point to submit a proposal. Justin, you can bring down the 2-pager concept, thanks. When we invite you to submit a proposal, at this point, we're gonna bring our teams back together. And this is also when we're gonna start introducing you to our implementation partners who are gonna bid on your proposal. And during this period as well, you will be interacting with our folks at NASA who work on the payload development team that they're going to help you get your research aboard a rocket. This proposal process, there's no time limit on this. We will work with you on your time, so we move as quickly as you would like. Some folks come to us and they want to develop a proposal and knock it out in 6 months. On other hand, there's some folks that come to us and it takes them up to 2 years to develop a very strong proposal and then for that to get approved and eventually get on a rocket. After you submit your proposal, we have an internal and external evaluation process that we're going to put your proposal through. And if it's approved, then this is where the real excitement comes into play, and that's getting your research, integrating your research and getting that on a rocket and getting up to the space station so that we can get results for you. So without further ado, I'm going to hand this off to Christine Kretz. Christine is going to discuss our lines of business and funding opportunities. And then thereafter, she's going to pass that off to Liz and Justin. Thank you.
Super. Can you hear me okay? Hear me fine. Okay, I wasn't sure since I stepped away and came back. The first thing to know is generally speaking, we have some buckets of types of research that we do here. These are lines of business or focus areas that we work on. If you were in the last presentation, and Liz talked a bit about our STEM kinds of projects, there are a number of projects that we do in education areas with students as young as elementary school, and sometimes with partners like Marvel or others who sponsor this kind of research. So STEM education and outreach projects are one kind of project that we do. So if you're in school, in high school and elementary school, that's probably a focus area for you. And we often post those on our webpage so you can see if you want to apply for those. Or if you're working with your own organization, the Boys and Girls Club or the Girl Scouts or a local robotics team, we welcome you submitting some ideas under the STEM umbrella to do projects with us. The next kind of projects that we often work with are science discovery projects. Those projects where we're trying to question the basics of how something can work in space and learn new things about organisms. And that could be, in the last session, some people asked about plant research and how things grow in space and how things get vascularized and how tissues grow or how cells grow. So those basic discovery science researchers projects are welcomed by our organization. Some of those are funded by government agencies such as the NSF. There are other things that we work with that are more commercially focused. And by that, we mean they're meant to be tech dev, technical development of a product, or interest in learning something that could become part of a product on Earth. The example that we had from the presentation prior is, as an example, Adidas. Adidas did some work on technical development of their product that they may eventually apply to the product itself here on Earth. And then finally, in-space production. So if your science requires a product to be made, something that becomes a product, to actually be manufactured in space, we're interested in hearing about those kinds of projects as well. And so those could be the kind of project that we discussed as called ZBLAN, which will be manufactured in space, or other kinds of products like tissues that get 3D printed, and those have to be made in the microgravity that makes them possible. So those are the areas that we are looking for particular projects in. And so your project likely falls into one of those 4 categories. But the question is about funding. And so funding is an opportunity that we work with many organizations outside of our own to help supply some needed funding for these kinds of projects. I mentioned STEM, and those are often sponsored programs. So a company or an organization will sponsor a program of student science and help fund those efforts. Other organizations that I mentioned are NIH and NSF, and they have funded many projects with us in the discovery science areas that include biotech and tissue chips and the kinds of work that help us discover new avenues in science. And we also have sponsored programs from companies and corporations who are interested in science. An example is that Target has sponsored some work in cotton sustainability. They have an interest in that, and they've come to work with us, and we put out a request for proposals in areas that interest that organization or company. So how do you find those opportunities to submit for one of those challenges? We always post those on our webpage. So the ISS National Lab webpage posts all of the challenges that we have coming out. If you're not on our mailing list, you can ask to be on our mailing list, and we will notify you of challenges that are coming out. You can also submit your own proposal that you may have gotten funded through other avenues. If you are a company and you would like to do research with us, we welcome your proposal, and you are more than welcome to work with us on what the funding requirements are. How much does it cost to put something into space? And the answer is it depends. on how big and how complicated and how much is required to do that. And Sean and the team are happy to work with you on estimates of costs and associated efforts that are required. So Sean, I hope I answered the questions that you needed me to answer. If not, I'll be here so you can ask me more.
Thanks, Christine. So now, thank you so much, Christine. Now we'd like to pass this off to Liz Warren. Liz is going to talk to you about the science and technology requirements that we're looking for out of your concept and proposal. Take it here from Liz. Thanks.
Thanks, Sean. So as stewards of the U.S. National Laboratory, it is our responsibility and our duty to ensure that the research launching to the orbiting laboratory brings value back to our nation. So all investigations are vetted, and there is significant competition. As both Sean and Christine described, there's a pretty significant process that is involved. We have an external peer science review process, but I'll tell you that one of the things that I will also encourage potential investigators to think about, but not worry too much about, and early in the process, that is you don't need to be an expert in the design of how is this all going to work, because during the process, once we think you've got a good idea, and please send in your ideas, even if you think you might need a little help fleshing it out, we're here to help you flesh out that idea. But if you're not quite sure if it'll work in space, or can we even do something like that in microgravity, we'll worry about that as we go. And as we described earlier in the presentation, and Justin will talk about this as well, there are these implementation partners that we've mentioned many times. They are the experts. They will talk to you about how do you do your experiment on your lab bench. Tell us what you do. Talk us through what you do normally. And they're going to translate that experiment into something that can be done by an astronaut like Christina. They may need to design some new hardware to make it work in space. Chances are there's already something that exists that is going to work just fine for your experiment. So that's kind of like the main point that I really wanted to make, but also to let you know that there is a pretty significant microgravity science community. There's a lot of publications that are out there. There's several journals that are dedicated to microgravity sciences. So in your PubMed searches or in your literature searches to see what might be possible, what's already been done, what is known, what's the edge of what we don't know, add a search term like spaceflight or microgravity, and whatever your science topic is, and that'll give you an idea of what's been done. And we've been doing microgravity research not just on the space station, but on the space shuttle. Really, more than 30 years, 40 years, we've been doing pretty significant microgravity research. So there's a lot that has been done, but don't let me discourage you, because there's so much that has not yet been done. And then I also want to remind you of one other thing, and Sean alluded to it, but kind of the very first question we ask you is, do you want to use microgravity to learn something about a process or something to benefit life on Earth? Or are you more interested in helping NASA to advance its missions in space exploration? And that's kind of an early bifurcation point where we will either connect you with some of our science friends over on the NASA side, or we'll take you from there and move you into our process. So I think that's all I want to cover right away. And then, of course, we invite your questions, and this whole session is designed to help you think through some stuff. So I'll stay on the line.
Thank you so much, Liz. And as Liz just mentioned, feel free to start submitting your questions. We would love to answer any questions you have regarding our submission process, funding opportunities, and just in general, how we can help you get your research up to the space station. I'm going to hand this off to Justin now. He's going to talk about the operation requirements and what he's looking for from an operation standpoint.
Thanks, Sean. Can you hear me okay?
Yep.
Yeah. Okay, great. So what I'm going to try to do is not scare you off, right? It's been mentioned earlier that doing science in space is hard, right? But that doesn't mean that it can't be done. And sometimes it's the hardest things that are really worth pursuing. So when an operations person is looking at your project, we're really looking to see, basically, is it feasible in space? Is what you're chasing something that our laboratory can actually achieve, right? So the ISS, as Liz mentioned, has a ton of facilities and a ton of experience doing different kinds of projects, but it can't necessarily do everything. And so taking that even a step further is, can the ISS National Lab, do we have the resources to support what you're trying to do? Sean mentioned some of those resources earlier, things like launch up mass, down mass, crew time, those kind of things. Those are kind of the primary resources that we look at, but we also look at things like our facility throughput, data uplink and downlink, lots of those kind of things. So what we try to do is when we look at those concepts, we see the experiment they're trying to do we think the ISS can do it? If it can't do it the way that you're thinking about it, maybe are there some adjustments that we could make in order to make your experiment more feasible or to increase your mission success? So just some specific areas that we're looking at as an operations group. Size is a big one, right? We only have a limited amount of size on every rocket, certain bag sizes, those kind of things, weight and volume. The crew time required. How much time is it going to take a crew member to actually work on this? Are we talking about a crew member for a few hours or something we can let it run? Those kind of things. And sometimes crew time seems like a nebulous concept, but we'll have experiments that run anywhere from less than an hour because it's just an uninstall or a reinstall, or it can be hundreds of hours for a rodent experiment because there's so much work being done to keep the rodents healthy and in the shape they need for those experiments. So I know that's kind of a nebulous concept, so that's something that we can work with you on to try to figure out what does it really mean we're talking about crew time. We're really interested in protecting your experiment at all stages. A lot of experiments require specific conditions, like being frozen after operations or before operations or those kind of things. So those are the kind of questions that we're going to ask you to make sure that we can accommodate all of your needs. We're keeping in mind that there's transit time to and from the space station. There's time that has to be worked on the space station, those kind of things. The facilities we have on board, Liz talked about a lot of those in her earlier presentation, combustion facilities, glove boxes, all those kind of things, what they can do and what they can't do. If you want to do a combustion experiment that requires, a foot or two of volume, we might not be able to do that because our combustion chambers are very small on space station. So that's where we get into how can we translate your experiment to a facility we have on board. I mentioned data requirements. We're going to look at hazards. Hazards on the space station are really important because we're trying to protect that crew and we're trying to protect those systems. You've probably heard that the space station is the most expensive system ever built by man. So it's it's something we're trying to protect. So it's not that we can't handle your chemicals and there's ways that we can't get around that, but protecting the crew and the vehicle are paramount to what we're trying to do. So we'll look at that and make sure that we can handle those things. And then your schedule. You probably are aware that space schedules are very long. And that's just because there's so much involved in trying to get it from translating from your bench to our bench on board, if you will. So we want to make sure that we can meet your objectives and your need by dates. And we're looking at it and we're looking at something realistic. Now, I probably scared you a little bit by saying all of those things. So what it comes down to, we don't need it to be so well defined up front, but the more well defined we can make it, the better that we can make sure we're going to be able to meet your needs when it comes to doing the experiment. We do have a lot of experience that have some requirements kind of creep in late on us, and we can usually accommodate those, but sometimes it makes it more difficult, or we've blown the schedule or something like that. So again, we're looking for as much detail as we can get up front, but you tell us what you know. And like Liz mentioned earlier and Sean mentioned, those implementation partners will help you get to that next step because they know what it means when we're talking about crew time. They know what their facilities can do and what the facilities on board can do. So I'm going to talk about implementation partners real quick. Sean mentioned we have 30 plus that we've done experiments with. They all have their own, a lot of them have their own facilities, or they're using NASA facilities, or they're kind of the stewards for the NASA facilities. So there's a lot of categories of what they can do for you. But really the key is they can use their experience to improve your experience because they know how these processes go. They've been in the NASA process. They understand what all of the data that's required at every step. And so that way you don't have to try to keep up with that. And it really improves your odds of mission success. So when it comes to choosing an implementation partner, there's a couple of ways you can do that. If you already know who you want to work with, then you're free to go ahead and reach out to them and say, hey, we think we want to do this project. Here's the concept. and they'll help you through it. If you don't know who you want to work with, then we have a process called the Implementation Partner Portal, where we will put your requirements out and they will let us, the partners will essentially bid on your project, and we'll do some back and forth where they're telling you how they think they can best translate your experiment into their facility or into however they think is the best way to do it on space station. And then you can choose which partner is the best fit for you. So I think with that, I've covered everything I wanted to, so we're free to answer any questions. So back to you, Sean.
Thanks, Liz and Justin. Thank you so much. Justin, I'm going to ping you again here. We had a question regarding some of our facilities aboard on station. Can we talk about some of those facilities and how those facilities could help advance the specific experiments that go up onto the space station? Thanks.
So I'll start this question, but we might have to hand it to Liz as far as what the science can actually handle. But so
sure.
I'll start with two of our favorite facilities, most used facilities of the microgravity sciences glove box and the life sciences glove box. Essentially, those are where we can install different modules to allow the astronauts to work with things that they normally would not be allowed to work on. If you watch some of those videos of Christina earlier, everything floats around in space, right? So the glove boxes allow us to keep whatever they're working with contained, so that if we are working with a chemical that might not be safe for the astronauts to work with, or we don't know exactly how an experiment's going to go, those glove boxes contain that science and make sure that we're working in a safe environment. And there's a whole bunch of things that can plug into those boxes, if you will, that enable them to do things from combustion experiments to dissections and almost anything you can think of. Those are the first two. We do have a couple of different combustion facilities, like Liz mentioned, the FUR and the SIR, which fluid integration rack, combustion integration rack, and they allow you to work with different temperatures. They allow you to simulate gravity at different levels between 0.001 G to all the way up, I think, to 2 G with some of the facilities, and do different combustion experiments in a safe and controlled way. We have a number of external platforms. Some of the commercial ones would be like the MISSI platform, which is used mostly for material science testing. How is my material going to work in space? How do radiation, atomic oxygen, some of those other things affect my material? But also that platform is being expanded to do things such as cameras and other, anything that can go externally is what they're trying to work for on the MISSI platform. We have a couple of others like the NanoRex external platform, the Craig platform, a bunch of other external facilities. So I don't know if there's, Liz, if there's any others in particular you think we should hit on while we're going through them, but there's 50 plus, I think, facilities on board that can handle different situations.
I think the only thing that I would add there is don't feel like we're trying to tell you there's only 50 facilities. In some cases, your idea may be a new facility. The ZBLAN glass drawing fiber experiments that I mentioned earlier, the technology is actually the facility, and how to actually do that. Now, of course, I think in most cases, those ideas actually go into the glove box that Justin described because of potential for off-gassing or because of temperatures. And so I think the message mostly that I want to get across is don't let your imagination be limited by what we're talking about. You may have an idea that is totally outside of what we've already thought about, and I hope that you do. And so don't worry about what exists already, because if you've got an idea, chances are there's a facility for you, or a modification to a facility that can be made for you, or maybe we just need a new facility. So don't worry about that.
Yeah, tacking on that, we'll help you find the facility if it exists, and if it doesn't, then maybe it's time to build one.
Thanks, Liz and Justin. So we have a question here, and I'm so sorry if I'm mispronouncing your name here. Shazina Kadiri. Again, I'm so sorry for chopping that up. But your question is, you would love to be part of a microgravity experiment, but you're not sure how to involve yourself with any specific ideas. You state here that your main field is in engineering, and so to you, it doesn't seem like you have much of an obvious relation or path in this area, but you enjoy being able to bridge the gap between the two. So would you have any advice to share to folks that are having trouble understanding how their specific field and their research that they're working on, how that could translate to microgravity? Liz, Jennifer?
I'll start, and hopefully this question helps you to see how you might make the same kind of connection. When I was an undergraduate student, actually before I got to my undergraduate university education, I knew that I wanted to somehow be involved at NASA. That's what I wanted to do, and I had no idea how I was going to get there and how that was going to work out. And so what I did is, while I was in school, is I just sought out, does anyone have a connection to NASA? Because I don't, and I want one. So I found professors, researchers at my university that had NASA funding. I talked to a school counselor, found out that, oh, this guy, this woman, this department has NASA funding. So I went to go talk to those departments and those investigators, and I told them, hey, I want to work at NASA. You have a connection at NASA. Can I work for you? And that's how I kind of got started. I found a laboratory that had a connection to NASA, and then I started learning how this all works. And that was back in the 90s. So now there's far more connections to NASA and the ISS National Laboratory. There are companies, maybe the company that you work for, bring it up with your management. Maybe you work at a place like Adidas. Who would have thought that a company that makes sportswear and sports apparel and sporting goods, who would have guessed that they would have a connection with the International Space Station? So wherever you are, I believe you can find a connection or find someone, and you've already found us. So it's just a matter of putting yourself in the right position. If you can't think of a great idea on your own, find someone who can and work with them.
Thanks so much, Liz. We have a question regarding our sustainability efforts, and I think Christine, you would be best to answer our efforts into sustainability. Thanks.
Sure. Thanks for that, Sean. And it goes a little bit to what Liz just said about somebody who wants to get engaged and doesn't quite have an idea for their own project. That there's a challenge that's going to be announced at the beginning of 2021. It's around advanced materials and using the International Space Station to find new kinds of materials that might be more recyclable or more reusable. And so that challenge will come out again in the end of January. And if you're thinking about that in advance, you and maybe a team of your friends can come up with something. Maybe you need to assemble some people who can answer that challenge for us. As far as sustainability, I mentioned earlier that Target had hosted a sustainability challenge around cotton sustainability. And the fact that you can use the International Space Station as a satellite that goes around the Earth and sees the Earth, there are a number of projects that have used the data that the space station picks up for information about better harvesting cycles, how climate is changing on the Earth. And most recently, there's a group that is using data from the space station, which was available to identify garbage in the plastics in the ocean, collect and harvest those, and then use that as feedstock. So they've taken data that was collected by the space station and have gone out to actually collect plastics and use them in a product. So you're using the outside by visualizing from the vantage point of space. So it's everything from new materials to just being able to view the station. And again, that challenge will be announced in the beginning of 2021 with a partner. So that is a funding opportunity. So if you're out there looking for something to direct your considerable talents to, we'd love to have you focus on that challenge.
Thanks, Christine. So we have a astronaut safety question here. Justin, perhaps you could answer this. This question comes from Carlos G. Carlos asks, how are the astronauts' safety assessed in reference to their experiments, and who conducts these assessments before giving the green light prior to launch?
So astronaut safety, right? So almost everything is looked at a lens with astronaut safety and vehicle safety. NASA has a panel called the Safety Review Panel, and they go through a multiple phase process where essentially you bring in your project, you kind of explain what you want to do, what the primary hazards are, and what they will do is levy requirements on your experiment saying that, okay, these are all the hazards that we think based on what you told us are out there. Now go verify that these hazards have been mitigated in some way in your experimental design. And so it's a multi-phase process. There's kind of a phase 0, which is just kind of introductory, and it goes through a phase 3. By the time you've gotten to that phase 3 safety, they have evaluated it, and what they've said is that you are safe to launch and you're not going to harm the vehicle. You are safe to be unstowed from the vehicle and then also installed or operated on by the astronauts, safe to go back once you've been activated, right? Because your experiments will hopefully change on board, and then safe to come home and be handled. So that's essentially how it goes, is that that panel looks at that crew health and says, how does this affect crew health? Some things that, like Liz mentioned, outgassing. It's something you might not realize on ground, but a lot of times, like let's say you've opened a new plastic shower curtain, right? As soon as you open that thing up, you probably smell some of that gas, right? Well, that's not acceptable on space station. They're scrubbing the air all the time, and the scrubbers can only handle so much. So if we do too much of these things that are outgassing, then that can overload our scrubbers and require more maintenance and those kind of things. So that's just an example of something they look at as it goes to crew health. There are some materials, some chemicals that will never fly on space station because they're combustible. The space station, I think, is a slightly oxygen-rich environment, so that's something to consider when you're thinking about what chemicals are there. But I wouldn't worry about that too much. Really up front, we can tell you, I'm sorry, that chemical is a no-go. Maybe consider using water as an analog, because you can get a lot of the same effects out of water at what you're looking at. Maybe there's other analogs that work even better. So a lot of times that's what we end up doing, is we want to use this chemical, but that one's going to be either just not approved by a safety panel or very difficult. Let's look at an analog and see if that can get you your science. So I hope that answered the question. I'm not a safety expert. I just know that they have a somewhat arduous process that the implementation partners can definitely help you through in order to get that thing certified for safety.
Perfect. Thanks, Justin. This next question, we have another scientist, Dave Brady, that has joined us from NASA. I think this question would be appropriate for David and Jennifer to answer. So we have Amina Hurd from the Phillips Academy out of Massachusetts. Amina has asked, are all fields of science welcome? Are some preferred over others? And what is the ISS best equipped to research?
Well, I think, yes, all fields are welcome. Are you hearing me all right, Sean? Just to make sure my mic's working. Okay, good. All fields are welcome. And actually, the way we determine the different research fields is that we use the National Research Council's decadal survey, and they determine categories of science like space science, earth science, physical science, biology and biotech, and human research and things like that. So we use a standard set of categories. What I would say in terms of what are most welcome is go back to what at the beginning of this breakout session, those questions about, is this something that you need to do in microgravities? Because basically what it boils down to is, can you use this platform in order to find a benefit for humankind or some other benefit that maybe NASA might be interested in? National Lab will concentrate on the things that are associated with commercial R&D, academic, government organizations other than NASA. NASA focuses on things that NASA is interested in, like exploration, maybe LEO commercialization for non-R&D projects and things like that. Jennifer, do you want to add anything to what I just said?
I think the only thing I'll add is, we had this question in the previous ones about types of science or fields of science for space station. We do have a publication online. You can search for it. It's called the ISS Researchers Guide. And it's broken down by different topics or different areas. So it's a place to look at fields you're interested in. It talks a little bit about the facilities and how we support that area of research, but it also has a little bit of kind of history, if you will, on what's been done in that field. So that may be something that you guys want to take a look at.
Okay, thanks, David and Jennifer. And an additional question from Amina. She's asked, are high school students allowed to participate? And perhaps Liz, you can talk to this point in our STEM education program we have here at the lab.
Absolutely. So I wanted to highlight the fact that yes, students can definitely participate. And there are a number of partner organizations that sponsor student investigations, so you don't have to come up with the funding all on your own. There's a great saying that a scientist in the field has said that, you know, if your high school can afford to have football uniforms, your high school can afford to send an experiment to the International Space Station. So there is some cost involved, you know, in the equipment and all of the analysis and what you want to do, but there are opportunities to find someone to help you with that. There are programs that we're associated with that actually take all of the costs. You just bring your idea, and you might have to compete with other students to get your idea flown, but that's a heck of a deal. So yes, absolutely. On both the NASA side and the International Space Station National Lab side, there are opportunities, even middle school students. And actually, I think we've even had elementary school students fly experiments. And what I would encourage you to do, and if I start naming organizations, I'm going to leave one out, so I'm afraid to do that. But you know, use the internet, Google, or a search engine where you can type in, you know, I want to fly an experiment to the International Space Station, and start exploring. And I promise you will find some ways to do this. And if you happen to be in a country other than the United States, that's fine too. Some of these organizations, they're sponsoring student experiments outside the United States as well. So there are opportunities. And if you're not having any luck finding them online, email that guy, Sean Pfeiffer, and he will send you a list. I'm just afraid to start naming names right now because I will certainly leave one out, and maybe there's some that I don't even know about. So yes.
Thanks so much.
SpaceStationExplorers.org.
Yeah, I was going to say, a little shout out on our website. If you want to try some things at home, if you are doing virtual homeschooling and you want to do that, that's Justin, that's an excellent point. Our website, and if you Google Space Station Explorers, there's some really excellent information there to get you started. It's some really terrific things that you can just use right at home.
Perfect. Thanks, guys. We have Liam here, and this actually is in addition to the last question we just asked. If we could further expound on international students and universities or non-U.S. citizens, can they send their experiment or proposal through one of our implementation partners like NanoRacks or Made in Space, Space Tango?
I just want to thank Liam for sticking with us. He's been participating actively in our presentation. So thank you, Liam, for hanging in here with us. I think that there are projects that go through our implementation partners that are CubeSat projects, Liz, and some things that include students from outside the U.S. So I think if your suggestion was that he Googled projects to space station, student projects to space station, and catch up some of that. And we might have some information we can send him in the mail about some groups that do support those. And I was thinking of some of the CubeSat projects that we've seen come from all parts of the world, if that's okay. I don't know if David and Jennifer have other suggestions.
I was just going to add, you know, from a research standpoint, there are a lot of international companies that also have U.S. subsidiaries or have a U.S. presence or U.S. base. And so, you know, that's another thing too, looking at multinational companies that also are based here in the U.S. For projects.
And if you want to go straight international, we do have some major international partners that work as partners on the station as well, that do research. European Space Agency, Canadian Space Agency, Russia has a space agency as well, the Japanese. And then there are some other countries that are exploring, expanding their roles in space. I know India is looking into that, even though they're not an international partner for ISS. The United Arab Emirates, we just recently flew, and as Christina mentioned before, an astronaut for them, and they're taking on training for additional astronauts. So if you're from a country that's associated with one of these space agencies, then you could investigate that as well. If you're not, I would say check into your country's interest in space and their space agency and see if they have any interest in sponsoring research going to the International Space Station. Thanks, Liam.
Awesome. Thank you so much, guys. Thank you, Liam, for these great questions here. We have a good question here. Christine, this one's for you. We have Russell Pounds, and Russell Pounds is asking here, Christina spoke about pizza night and the oven used. Is this the same zero-G oven described in the chocolate chip cookie release involving the Hilton DoubleTree? He has two questions here, so we'll start with his first question.
You're asking me if it's the same oven?
Yes.
I don't know. Liz probably. Liz is it's not the same oven, is it, Liz?
Yeah, I can take that one. It's not the same oven. It's a different piece of hardware installed elsewhere in the space station. So it's the second one.
Okay, perfect.
Yeah,
thanks.
And I was going to add a little known fact. I don't think that the astronauts were allowed to eat those cookies. They were an experiment. Isn't that right, Jennifer? So you can't eat the experiments.
That's right. That's right. But we do. We're not going to be cruel. We do fly some treats for them from time to time too. So.
They have eaten some station-grown lettuce.
Yes, our veggie facility.
Well, you can't eat some of the experiments, then. That's good to know.
The second part of this question here, Christine, Russell is asking, I've seen press releases on the perfume company. Can you talk more about the Estee Lauder media event and how media demonstrations are developed?
I'm going to let Jennifer or David talk about that small percent, 5% of the payload that NASA has that goes towards some of these commercial, not experimental. And then I will follow that, talking about other things that Estee Lauder is jumping in to do with us. So David or Jennifer, you want to talk about the 5% payload?
Sure. David, do you want to talk commercial allocation?
Sure. There's been some confusion generated by the fact that National Lab for many years has been involved in working with commercial companies to do research and development. And sometimes that research development leads to a business plan, use of their business plan to demonstrate that and to try it out. And sometimes it leads to technical development of demonstration of products that they can eventually go on to make a profit from. But in the end, what National Lab is looking to do is to partner with companies that are doing, commercial companies that are doing R&D. A little over a year ago, NASA announced an initiative that we call the LEO Economy Initiative, the Low Earth Orbit Economy Initiative. And the idea was that the Congress of the United States, through the 2017 NASA Transition Authorization Act, and subsequent to that, NASA as an agency has started a 5% portion of our allocation on the NASA side to utilize towards what is most easily described as commercial non-R&D, as opposed to National Lab doing commercial R&D. And what that means is that we're looking for companies to come and develop the market in the low Earth orbit so that NASA can eventually become one of many customers. NASA's best focus is on the new stuff, like, for example, exploring, going out beyond low Earth orbit at this point to the moon, to Mars, to different areas, to Gateway and stuff like that. So the idea is that if you build a low Earth orbit economy and you have commercialization there, they will build the infrastructure that maintains the pipeline. For example, we went and partnered with a couple of companies to get cargo delivered to the space station. And so that has turned into a regular commercial activity where these companies own these vehicles and we buy that service. And recently, I know everybody's heard the news about now that we're flying astronauts on commercial companies as well to provide that infrastructure. And so now the idea is to take the assets in low Earth orbit to include the space station and maybe future commercial space stations, private astronaut missions, commercial modules, and start developing that market. So Estee Lauder is simply a demonstration of interest by a company to see if we can take a product. If they have asked us to take a product up on orbit, have it photographed, and see what sort of marketing they could do through their social media in order to see if that is potentially a low Earth orbit market. And if you don't try some of these things may look like a publicity stunt. Actually, what we're looking to do is to try and figure out where a market can be developed in low Earth orbit, and let the market, let the commercial companies decide what to follow and what to try out. So.
Yeah, and let me note that they are paying for the payload, so it's not that it's being done for free at taxpayer expense. And the second thing is it doesn't take away, that 5% doesn't come out of research. So we're not detracting from research that is done. And last but not least, we're really proud to work with Estee Lauder. They're a wonderful partner. Their chief research technology engineer will be working with us to help us with a sponsored program that they're going to do with us in 2021. And they'll help us to select projects around the packaging that I mentioned. And so we are super happy to be working with them, not only contributing funding, but contributing their science expertise to the payloads. So they are a fantastic partner. Likewise, Adidas has flown in that 5% spot with some of their products. And I can explain a little bit about that. They needed a picture of the product that they were doing research on. So Liz mentioned the Boost shoe, but because their research shows it doesn't look like a shoe when they're doing research, and they wanted a picture of the shoe. So they're doing both the science research and the cool take a picture of it in space. So it's a win-win.
Good question. Thank you.
Thanks, guys. We have a question here. I think, David, you'd probably be best to answer this one. So how much international collaboration is there between the experiments, especially in either planning or logistics or with data sharing?
I'm actually going to defer to Jennifer. She has more experience in working with our international partners on science and research.
Yes, so we do both. We do, data sharing. We also come in, so ideally we'll be in a situation where we're working with international partners. The science community is very small. We're all going to the same conferences. You all get to know each other. You have two scientists who want to collaborate. The most efficient thing that we all want to do is, make the most efficient use of our resources with our international partners as well as NASA. And so researchers will either design an experiment ground up, and then, we'll determine kind of the contributions, and then they share the data, they share the data analysis, they publish together. We do that very frequently in both life and physical sciences. There will also be, where a scientist is doing an experiment and another scientist just needs part of the data or just needs kind of like a missing piece for some work they've been doing on a different experiment. And so we also have agreements and collaborations in that sense too. But we do collaborations with all of our international partners.
Okay, thanks, guys. Here's a good question coming from Carlos G. Does the ISS National Lab have any association with NASA's SBIR and STTR grant program?
Well, that's a very good question, and yes, we do. So some of the people who start their research with us develop their technology, test out their efforts. They kind of try out their recipe with us, if you will, and then based on the strength of that research, put in for SBIR and other NASA grants. And there are several recent examples. Lambda Vision and Space Tango developed a project together where they're working on a retinal chip that's an implant, and then that went on to SBIR funding. Maiden Space is an organization that has done a number of things, starting with our team, and worked their way over. And we're also pleased to be helpers of NASA's SBIR, and so people like Liz, as an example, read and review those proposals that come in and contribute in that way to helping to select. So we're really happy to be teamed with NASA on those kinds of grants.
Perfect. Thanks, Christine. Okay, we're getting near to the end of our session here. If you have any more questions here, we would love to take them. Let's see here.
I have a question for you, Sean. How about I ask you a question?
Okay.
So you talked a little bit about how long it takes to write a proposal, and it's how fast can you write? Is that, how fast can you write a proposal? But once somebody has a proposal that is approved, and maybe this is a question for you, and Justin and Liz, how long does it take to get it on a rocket? So I've written my proposal, it's gone through review, it's gotten a thumbs up, we drive. How long does it take to get to space?
Yeah, Justin would be in a better position to answer this, but in short, and Justin, you can expound on this. In short, it can take, for something very simple, but it's something that we definitely want to get up there. It's a research priority for us. We could get you up there in about 8 months. Some experiments typically take up to 2 to 3 years before we finally get a seat for you on the rocket. And Justin, Justin can further expound on this.
Yeah, I would say typically you can usually get there in 12 to 18 months. It just depends all on complexity of your experiment. How new is it? Are we using a facility already on board and we're just kind of plugging something in? So those are all different things. It depends on the partner you choose. Some partners can react a little faster. And then sometimes it comes down to priorities. A great problem that we have now at the ISS is that we have a lot of research that wants to go there. And so now maybe even your experiment's ready, but we've got a long line of research that we're trying to get done. So I'm not scaring people off. We want to get as much as we can so that we can continue to have that problem. Especially since we're going to have more crew members on board. As mentioned earlier, we're going to have the crewed flights coming from SpaceX and Boeing within the next year or so. Hopefully the first one in the next month. That's going to give us a lot more crew time on board. So we're going to be able to do more experiments that we've been able to do in the past. And oh, by the way, that crew member is almost completely dedicated to science. So that's, a 40-hour work week every week for that crew member that is essentially for science. So that's my point, is that even if you're ready, sometimes you might have to wait for opportunity, but in general, we can fly you within 12 to 18 months.
That's pretty quick. Thank you.
Thanks. And one last question here before we conclude. Christine, or perhaps David, Jennifer, this question comes from Guy. His question is regarding IP. So when we get research up to the space station, is that IP protected? Is that IP belong specifically to our principal investigators?
Yeah, let me take a crack at that. So the IP, the ownership of that intellectual property belongs to the investigator. We at the National Lab don't have any rights to whatever it is that you're working on. There is, however, a flow down from the national government because you are using a facility that is the national, in the national interest. There is something called a march-in that could happen if your research is deemed necessary by the U.S. government for the safety and betterment of the planet. They have never exercised that right, and it is not expected that would interfere with your IP. I don't know if NASA, if you wanted to elaborate on that, but we have never had anyone's IP be extracted by the U.S. government. Anything else? Is that good? Did I answer okay?
Oh, yeah, I think that's good.
Yeah.
That's a
All right.
that's a great
So
answer.
generally speaking, your IP is your own, and we will take none of it from you.
Perfect. All right. Well, we're at the conclusion here. Does any of our panelists have any final words? Anything that they would like to say?
I can only say that I would like all of you who would like to submit a project to keep Sean very, very busy with your questions, and he will send you the concept form, and that there you go. There's the information that you need. But Justin, Liz, and the team would be really happy to have your proposals and your ideas and your questions come at it. So keep us busy. Even after this call is over, we're really interested in what you think.
Thanks, Christine. Yeah, always got to keep me busy here at the lab.
I know.
It never stops. Thank you so much. So thank you to everyone for coming out to join us for our very first virtual destination station. This couldn't be a success without you guys and your participation and great questions. And so, as Christine had mentioned, you got to keep me busy here. So if you have any concepts that you would like to pursue, I would like to hear from you. Feel free to email me. And if that concept gets approved and it goes to a proposal and that proposal gets approved, we will be sending you a gift bag. The National Lab and NASA teams will be sending you a gift bag with some items in there that you will not be able to get anywhere else. So that's only if you get a winning proposal that gets approved here at the National Lab. So in the next few days, look out for an email from myself. I'm going to include my contact information along with some informational links. And then within a week, I'm going to be sending out a survey, and I would greatly appreciate, our team would greatly appreciate if you could take the time to go through that survey, take a few minutes. It will help us improve our processes for our next virtual international destination station, which is going to take place in March. So thank you again for joining us, and dream up. Take care, everyone. Bye.